Hello class and welcome to Physical Geology. Today I want to look a little bit at the sedimentary rocks identification parts. So in your lab, the last section for the sedimentary rocks lab is dealing with identifying the unknown samples. And so here we have about 9, maybe 10 samples. And what I'll do, I'll go through each one of these and I'll point out some important elements of the samples. And then your job will be to correctly identify the rock name based on the data tables that are in your lab. Now let's look at the first sample here. We'll look at the sample number 10. And number 10 here, we'll see that I can visibly see grains, right? I know that now it's going to be on the sand size region, right? And remember in lab, these little size ratings, so the Wentworth scale. And in the Wentworth scale, you can see that it's kind of on the middle of the sand range. So we definitely have some sort of sand, and which is cemented, so it's some sort of sedimentary rock. And if we look closely, we'll zoom in a little bit here. These grains are primarily vitreous. If you could scratch these individually, you'd see that they would have a hardness of around 7 because you would not be able to scratch them. So they're cemented, they're sand size, they're moderately rounded, and they're primarily about 99%, 98% that hard vitreous mineral. And those minerals are obviously broken pieces. Remember the word clast, C-L-A-S-T. So they're broken clast. So your job is to identify this rock. One, is it siliciclastic or is it chemical biochemical? And two, based on the composition, the mineral composition, what's the name of this sedimentary rock? All right, so that's number 10. We'll move on to another rock here, so number 51. And 51, one thing that right away is I see that there's some fossils in this sample here. So when we look at it a little bit more closely, I can see a fossil shell right in this region here. And more importantly, I have some larger samples of this one. And this sample you can see, for sample 51, here's another bigger piece of it. You can see it has some horn corals here. So this is a big horn coral. We have some brachiopods in here. So in other ways, it's full of fossils. And another thing that we can test out is for sample 51, we'll bring our original sample back here. If we put a little bit of hydrochloric acid on it, you'll see that it'll have a reaction, which means it's composed of calcite. So the composition of this mineral, of this rock, is calcite in it. It has fossils. And another thing that I noticed about this rock, and we'll put another sample up here with some bryozoan fossils in it, the little bryozoans in there, is that this sample is not very porous. It's pretty well cemented. All right, so again, your job, is this a siliciclastic rock or is it a chemical biochemical rock? And based on the composition, it has calcite, it reacted with the acid, you could figure out what type of chemical or biochemical rock it may be. So anyways, that's sample 51. Then we'll look over here at sample number 1. The first thing you'll notice about this sample number 1 has these kind of pinkish to red minerals that have really good straight cleavage. So I can see these kind of sharp edges on these, kind of sharp edges. It has 2 directions of cleavage. A salmon pink mineral. Usually this mineral is considered a felsic mineral. So again, when we look for this one, we'll compare it to the grain size here. And if we zoom in a little bit here, we'll see that here we're looking more on the gravel size, right? So we're on the gravel side of this one. And again, your job is to determine whether this rock is siliciclastic or chemical biochemical. Also, look at the shape of the clasts, the broken particles. Are these rounded or are they angular? And then that can help you identify this rock. So that's sample number 1. Now we'll go over here to the next sample, which is sample number 0. And one thing about this sample here, sample 0, it's very fine grained. You can see it's kind of coming off on my fingers here. And so this fine grained sedimentary rock is composed. So your job is to figure out whether it's a mudstone. It could be a chert. Remember, chert is microcrystalline quartz, or it could be some sort of finer material like a clay stone or a chalk. And you can see it's really soft. So the fact that I can scratch it with a knife tells me that it's not chert. Remember, chert is microcrystalline quartz. This is not quartz. And then I'll do a little acid test on this, on the little corner here, see what happens. And you can see it reacts pretty vigorously, only because it's very fine grain. In fact, I would say this is mud size, very fine grain mud size, reacted acid, which means it's calcium carbonate. So again, your job is to tell me whether it's a siliciclastic rock or a biochemical rock. And based on its mud size, fine grain nature, and the fact that it reacted so easily with hydrochloric acid, determine the name of this rock. So again, that's sample number 0. Now another one that looks very similar to sample number 0 is sample number 22. And 22, the first thing I notice about it is it's also mud size, very fine grain. There's some little laminations or layering indicating that this was deposited or laid down. So again, a sedimentary rock, fine grain mud size. But also note that when it breaks, because this one I broke here, it has this curved fracture here. And that's called the conchoidal fracture. So it has conchoidal fracture. And then we'll look at it in terms of hardness, and I see that I can scratch it with the knife. See the scratch I put in there? So that's telling me that it's not hard. It's a soft material. And so it could be another one like the sample 0 we saw here, but let's put a little bit of acid on this one and see what happens. And nothing happens with this one, right? In fact, that material soaks in pretty easily there. Your job for this one is to determine whether it's chemical, biochemical, or siliciclastic. And so again, use your data tables to determine this sample number 22. So another one is number 38, and this one is microcrystalline. I cannot scratch it with my fingernail, so it's a little bit harder than my fingernail, but I can scratch it with a knife. See the scratch I put in it? And then it's pretty densely packed in there, and when I put a little bit of acid on there, I see that it does react again. So it's a mud-size chemical rock. So this is really a chemical rock. So your job is to determine what type of chemical rock this is here. So again, this is sample number 38. Let's look at this sample number 27. 27 is an interesting rock here. Again, right, the first thing I notice are those pink feldspars, right? So the pink feldspars, and they're somewhat rounded, but they have kind of some sharp edges in there. The pink feldspar, and I see some layering in there. I also notice there's quite a bit of that lighter colored mineral, clear mineral, which is quartz. And so in this case, it's about maybe equal amounts of quartz and feldspar. If you look in here, maybe 50% potassium feldspar, about 50% quartz. So 50% quartz, 50% potassium feldspar. Again, and we're also looking for the roundness. You can see they have some edges to them, but then some are kind of more rounded. But if we look at the size rating for this one, we'll find that these are mostly in the coarse sand region, right? So it's still some sort of sand size sediment, and more in the coarser sand region. And you can see there, in terms of sorting, it's not that well sorted compared to number 10. Number 10 is very well sorted, but this number 27 here is poorly sorted, right? So it's a little bit less mature than sample number 10. All right, so your job is to determine whether, again, it's siliciclastic or chemical biochemical. And then if you think it's siliciclastic, determine the name for this sedimentary rock here. Now for number 3, this next sample here, it looks similar to 27, but right away I see in this one, again, the sorting is not very good, and it's composed of a lot of broken grains. And if I look a little bit more closely, especially on the top here, kind of the surface here, I see these grains are very well rounded. Right? They're pretty well rounded, poorly sorted, and when I look at the size rating, these are more in the gravel size rating, right? More in the gravel size. So kind of a finer, pebbly gravel here. So again, is this rock? The grains are rounded. They're cemented together. Now your job is to determine whether it's siliciclastic or chemical biochemical. Again, we're going with a gravel size sediment here. So that's sample number 3. And then sample number 50, right away I see this little snail fossil right here. A little snail fossil, and you can see kind of these little holes where kind of the corkscrew of the snail goes in there, and some of the little shells in here. And so again, it's probably going to be biochemical, and then when I put some acid on here, you see it's going to react in the acid. So again, it's some sort of calcite, so rock composed of calcite, but with fossils in it. And then this is sample number 50, right? Sample number 50. But the other thing I want you to note about this one, that there's a lot of holes, or it's porous, as opposed to sample number 51, which also had fossils. Number 51 here is pretty well cemented. So 50 is porous, 51 is well cemented. So again, try to figure out whether again, well, obviously it's going to be some biochemical rock here. So give it the name for this rock here using your data tables. Now the next sample here is sample number 16. And the first thing I want you to notice about this is I really don't see any grains, really fine grains. So it's going to be mud-size sediment. And also note that it's very flat, right? So that's a word that I call fissile. It's black, and it also, this one doesn't really show it as well. But it's black and fissile, fine grain. So again, mud-size sediment. I don't see any grains. It's not going to react in acid, so I won't even bother putting acid on it because I know it's not going to be calcite. So your job again, if it's siliciclastic and mud-size, note that the general structure of it is fissile, right? So your job is to name this sedimentary rock number 16. Now the next rock here is number 78. And 78 looks again like, it looks a lot like number 22, a very fine grain. It looks a lot like number 38 that we just looked at. Again, it's, probably microcrystalline. But one thing I noticed about this one, if I try to scratch it, I see it's very hard. I cannot scratch it. In fact, it looks like the knife is, metal is being put on here, so I can kind of rub that off. So this is harder than the knife, which is probably hardness 7. And it is a microcrystalline rock, so it's probably a chemical rock. So obviously if it's hardness 7, it cannot be calcite. It's not going to fizz because it's not going to react with acid because it's not calcite. It's too hard. So it's probably the mineral quartz. And this mineral, or this sedimentary rock, is really a deep marine rock forming in the deep ocean. In fact, I have some other samples of this one here for you to, I wanted you to compare. So here's a red variety of that same sample here. Again, very hard sedimentary rock, composed of little microfossils actually. I talk about these in my lectures. The little microfossils are called radiolarians. All right, so that's number 38. So again, mud size, very hard. So the mineral is probably quartz, and so you're going to look at the chemical rocks and determine what sedimentary rock this could be. Finally, the last rock I want to point out here is this rock here. And you can see right away that it's composed of crystals. I see the cleavage of the crystals there. And if I look carefully, I see that this has some straight edges on here. So the texture of this rock would be crystalline. And just as a clue for this one, the hardness of this mineral is less than your knife because I can scratch it. See the scratch I put in there? And if you put acid on it, it's not going to fizz. In fact, we'll just try the acid test on here. And so it's not fizzing. All right, so it's not calcite. So it must be something else. In fact, this rock forms in an arid environment where water evaporates and leaves behind these crystals, usually like in a salt flat or something. So again, crystalline sedimentary rocks is probably some sort of chemical, some evaporite. And so number 25 here, and you can sort of see the two directions of cleavage. Actually, this mineral has 3 directions of cleavage, and it has cubic cleavage, so that should help you. So the mineral has cubic cleavage, 3 directions, softer than the knife, but harder than your fingernail, so it's not gypsum. So your job is to determine what this rock is. All right, well, that's it for now.